Hey, how's it going? My name is Grant Altman. I live in Jacksonville, Florida. Going to be a sophomore at UCF. And today I'm going to be showing you and teaching you how to find the trigonomic values from a point on the XY plane. So let's say you have a point and the question asks you on a test or on a worksheet, you have this point, 3, 4, and it's asking you to find the trigonomic values from that point. So the first thing I like to do personally is write out a triangle on the graph. So you have 3, because this is the x-coordinate, and the x line, 3, 4, to get to this point, right? You have theta, you have the right triangle, and then you have c. So usually what I do to find c is do Pythagorean theorem. However, in this case, in which Pythagorean theorem real quickly is a squared plus b squared equals c squared. However, in this case, I don't actually have to use that because this is one of our known right triangles, which is a 3, 4, 5 triangle. So automatically, we know that C is 5, which is C, B, A. That means also that this is angle A, angle B, or theta, and angle C, which is obviously the right angle. So from this, and the trigonomic values is sine, cosine, tan, cosecant, secant, and cotangent. All of theta, obviously. Theta and theta. So what do these equal? Okay, so sine equals opposite of theta, so this side, over the hypotenuse. So opposite side over hypotenuse. Cosine is the adjacent over the hypotenuse. Tan, some people think of it as sine over cosine, which it is, and sine is opposite, cosine is adjacent, so opposite over adjacent. So opposite over adjacent. Cosecant is 1 over sine of theta. Secant is 1 over the cosine of theta. And cotangent is 1 over the tan of theta. Okay? So now that we know what all these are and how to get them, now we just gotta really just plug it in, right? So sine theta, we'll start over here. Sine theta equals opposite over hypotenuse. So 4 over 5. Cosine of theta equals adjacent over hypotenuse. So 3 over 5. Tan of theta equals opposite over adjacent. So 4 over 3. And this is where it gets a little interesting. So cosecant of theta, which is equal to 1 over the sine of theta. But sine is 4 over 5, right? So that would mean that this is 1 over 4 over 5. And that's just not that's not a fraction. That's a little weird. Why does it look like that? It's like 2 lines, right? You can have 2 lines in a fraction. So the way you change this is you have to times 5 on both sides to cancel that out. So that actually equals 5 over 4, otherwise known as the reciprocal. So what the reciprocal is that if you have 4 over 5, the reciprocal is 5 over 4. If you have 6 over 8, the reciprocal is 8 over 6. So the reciprocal is just the switched version of a fraction. So for the cosecant, which is 1 over sine, you get 5 over 4. That's the cosecant. For secant of theta, you have 1 over the cosine of theta. So very similar to this, you have to do the same thing, right? So the cosine is 3/5. So you have 1 over 3 over 5. So to do the same thing, times 5 on top, those cancel, right? So you get 5 over 3. And then for cotangent, it's also the same thing. So you have 1 over the tan of theta. And that equals 1 over 4 over 3. So in this case, you have to times 3 on both sides. again, just like you did for cosecant and secant, those cancel, and you get 3/4. And this is the same technique you do for every trigonomic value given a point on the xy plane. It's the same technique. You have to first find the triangle, and then you have to, if it doesn't give you C and it's not a given right triangle, you then have to find C, either using Pythagorean theorem or a different method And then once you have all of the sides, you then can find all of the trigonomic values.